So good evening and welcome to the Beef Cattle Research Council's webinar on antimicrobial use and resistance in beef cattle. My name is Stacy Domalewski. I'm the Extension Assistant for the Beef Cattle Research Council, and I'll be your moderator for tonight. The session should last for approximately 1 hour, but may go a little longer depending on the questions that are asked during the question and answer period. If you're on Twitter, please tweet along with us tonight using #BeefWebinar. We are going to be recording this session, and I will email out a link to the recording within the next couple of days. So if you miss hearing anything tonight and want to watch it again later, you can. But I would also encourage you to take some notes tonight to help you remember some things a little later on as well. So of course, for tonight's webinar, you're going to be able to hear and see our presenters, but we can't hear or see you. So if you want to communicate with us, just type into the small chat window on the control panel on the side of your screen. If you have questions or comments for either of tonight's presenters or myself, that's the place to do it. And feel free to send your questions in at any time, but we'll answer them towards the end of the hour. If your internet connection is being a bit slow tonight, it might help to close the webcam window. You won't be able to see our presenters, but it'll hopefully make the audio come through a little more clearly for you and the slides load a little bit faster. All right, so let's get started. So here's what we'll be covering tonight. We're going to start with Dr. Reynold Bergen talking about antimicrobial use and resistance. And then we'll hear from a veterinarian's perspective on the same topic by Dr. Craig Dorin. We'll open it up to some questions from you, and then end with where you can find a little bit more information on the topic. But before we get started, I want to make sure that you have all heard about the first ever Canadian Beef Industry Conference. There's never been one before, and so for the first time, 4 of our nation's beef industry organizations are joining forces to host this fantastic event. It's going to bring all types of people in the different sectors to Canada's beef industry together under one roof. So there's going to be several workshops and sessions that talk about how on our farms and together as an industry, we can increase the value of carcasses, improve our industry's competitive edge, how we can collaborate more seamlessly within the industry and connect positively with consumers and governments, and of course, talk about productivity with topics to help you and other producers reduce your production risk and become more profitable. There's going to be several interactive workshops, so if you like these BCRC webinars, you're going to love the interactive, interesting, and lively seminars that are going to be held at the Canada Beef Industry Conference. Plus, you're going to get to hear from a keynote address from the CEO of one of Canada's largest independent marketing firms, Arlene Dickinson. There's also going to be several of the industry organizations will be hosting meetings and presentations so you can get a better understanding of how they work on your behalf and have your input heard as well. You're also going to have a great time. There's going to be a gala, live music, a supper at Heritage Park, and some good old-fashioned hospitality. We're going to be staying at the Grey Eagle Resort and Casino, so you can enjoy all those amenities. And if you're a golfer, you can play in the Canadian Cattlemen's Foundation Classic Golf Tournament to help raise dollars for our industry's charitable foundation. And if you're going to Calgary, you might as well make a holiday out of it anyways, and take in the sights of the city or head out to the mountains for a vacation. So mark the Canadian Beef Industry Conference in your calendar, August 9th to 11th in Calgary, Alberta. Early bird registration is open now, and you have until June 15th to get that reduced rate. So for updates, follow the Canadian Beef Industry Conference on Facebook and Twitter, or keep an eye on their website, www.canadabeefindustryconference.com. So now that I'm sure you're going to all register for the Canadian Beef Industry Conference, we'll get back to tonight's webinar. So I'm pleased to introduce Dr. Reynold Bergen. Reynold is the Science Director for the Beef Cattle Research Council. In a nutshell, his job is to communicate research to beef producers and explain beef production to research. So if you subscribe to the Canadian Cattlemen's magazine, you will recognize him from his column that he writes monthly as well. We can't hear you, Reynold.
Can you hear me now?
There you go.
I've got too many mute buttons. All right, so I can start. There's two main things that we're going to talk to you about tonight. I am going to talk about whether antimicrobial use in beef production has implications for human health. And then when I'm done, and hopefully that won't be too long, Craig is going to talk to you about antimicrobial use in beef production and whether that has implications for cattle health. So from the human health perspective, what's the concern? The concern is that antimicrobial use, whether we're using them in livestock, in humans, or pets, or aquaculture, or horticulture, or beekeeping, or wherever, is going to increase the risk of antimicrobial resistance. That is a fact. There's also concern that some of the antibiotics that we use in livestock are closely related to those that are used in human medicine, and that's a fact as well. There's concern that antibiotic resistance can be transferred among different kinds of bacteria, and that is a fact. And there's also a concern that those things might all add up to reduced effectiveness of drugs that are used in human medicine. And that's actually where the big question mark is. There's no, well, I'll show you the evidence that we've got. So, I've been asked before what the beef industry's position is on antibiotic resistance, and it's pretty straightforward. We're opposed to antibiotic resistance, and there's a couple of reasons for that. And obviously, we need animal health products to be effective when our animals get sick. And we need those human drugs to be effective when we get sick or our family gets sick. And we also need our beef consumers to be confident about how the beef industry raises beef and how safe the beef is that they consume. So I'm going to give you a couple of quick facts, AMR 101. And the first thing you need to know is that antibiotic use doesn't cause antibiotic resistance. Antibiotic resistance is a naturally occurring phenomenon. And in fact, this is a slide that I stole from Dr. Tim McAllister from Ag Canada in Lethbridge. If you're going to steal, steal from the best. So I stole from him. And the point of this slide is that there have been caves in New Mexico that have been isolated from humans for 4 million years. And when they finally cracked these things open and went exploring, they did swabs for bacteria, and they found antibiotic resistance in those caves that have never encountered humans, at least since they developed antibiotics. And the same with permafrost. They find antibiotic-resistant genes in permafrost from hundreds of thousands of years ago. So, and the reason that they're finding these antibiotic resistance genes, even when there's been no antibiotic use, medical or veterinary, is that these antibiotics are natural. They're produced by antibiotics. And the reason that is that antibiotics, they're sort of like people, they're sort of like countries, and if they find a place to live, they want to defend that territory. If they see a place that they like a little better, they want to take it over and move in there. And they're producing antibiotics and secreting them as a way to defend their territory and to gain new stuff. And so bacteria that are getting invaded are developing resistance to these antibiotics to defend themselves, and then they're creating their own to try to fight off the other bacterial invaders. So it's kind of an ongoing battle between bacteria that leads to kind of a natural underlying level of antibiotic resistance that is always out there. This is another slide I stole from Tim. I'm not that good an artist. So antibiotic resistance is natural, but if we use antibiotics, if we add extra ones, whether it's through these various ways that they are used, we can really speed up the rate at which antibiotic resistance develops. So there's actually very little evidence that antibiotic use in Canada's beef cattle industry is posing a threat to human health. And the reason that that I can say that with confidence is because of the Canadian Integrated Program for Antimicrobial Resistance Surveillance, or CPARS. That's a program that's run by the Public Health Agency of Canada, and they do regular targeted surveillance of antibiotic resistance in healthy cattle that are entering slaughter plants, as well as retail meat in grocery stores. And they look at a variety of different bacteria. And this has nothing to do with industry. This is a government program, so we have no influence over it. We just get the same reports that are publicly available to everybody else. So I'm going to tell you what those results are. But before I do, I need to explain that there are different kinds of antibiotics. Not all antibiotics are equally important when it comes to human medicine. There's actually 4 categories of them. The low importance category is antibiotics that aren't actually used in human medicine. And then there's a group called medium importance antibiotics, and those are rarely used in human medicine anymore. They're sometimes used for really minor things, like tetracycline is sometimes used for acne in human medicine, so not for major things. There's high importance antimicrobials, and those are used to treat more serious bacterial infections. But if those don't work, there's still another category we can go to, and those are the very high importance antibiotics. Those are the drugs of last resort, and those are essential for serious infections. And the problem with these is that if we have, if I'm infected with a bacteria that is resistant to all 3 of these categories that are used in human health, that's a superbug. And if I'm battling an infection that's resistant to everything, that means that comes down to a fight, and this is Tim's allegory that I'm stealing here. It comes down to a fight between my immune system and that bacteria. And if my immune system wins, I get to live another day. But if the bacterial infection wins, then my family gets flowers. So this is a really serious thing. Multi-drug resistance is a huge important thing. Now, the other thing you need to know is that in beef production in Canada, we use drugs in every single one of these categories. We use ionophores like Rumensin, Bovatec, those sorts of things that aren't important in human medicine. We do use tetracyclines, Oxytet, and those sorts of things, Liquamycin. We use macrolides, so things like Tylan, Micatil, Draxxin, Zaprevo, Zactran, those are used. And we also have some in the very high importance category. Now, Craig can talk about this as well, but I think I'll introduce the concept of cross-resistance here. And what that means is that some of these drugs, like Exceed and Xenil and Ceftiocil, those are virtually identical. They're almost the exact same molecule. And so if you have a bug that's resistant to Exceed, it's probably going to be resistant to these 2 as well. Same thing with these 2. These are fluoroquinolones. And if you have a bug that's resistant to Baytril, A180 is probably not going to work on it either. And the same with the macrolides. If Micatil's not working anymore, switching to Draxxin, Zaprevo, and Zactran probably isn't going to help for very long, because if it's already got resistant to one of these, it's going to be pretty easy to get resistance to these other ones because they're really closely related. Now, so when CPARS does surveillance in cattle and beef, what you want to see ideally is 0 resistance to anything, but that's impossible because antibiotic resistance is natural, so there's always going to be some baseline level of resistance. But what we can hope for is next to no resistance to these, really low resistance to these, and if we see a little bit of resistance to these, it's a little less of a concern. And in the surveillance they do in beef cattle, that's exactly what we see. We see next to no resistance in the very high importance. We see really low resistance in meat in high importance, and a little bit more in the medium importance drugs. So on the beef side or cattle side, antimicrobial resistance is looking really good, and I would dare to say that any other livestock sector in Canada would be proud to have results that look this good. And they see exactly the same thing in beef. Virtually nothing here, a little bit here, and a little bit more here. So Canada's doing a really great job in the AMR side in both cattle and beef. And the reason for that is the way we use them. There's 4 bars here. You can only see 2 of them though, because these 2 are really low. If you look at the the doses of antimicrobials that are used in feedlot cattle in Canada, only about 1% of them are from the high and very high importance category. This isn't comprehensive data. This is pretty limited data. This is only from about 10,000 feedlot cattle from a couple of years ago. So it's kind of limited, but it's the best information anybody has in North America. And it was due to your checkoff. It was research that we and Alberta Beef did. When you look at antimicrobial sales for veterinary drugs in general, it's not 1%. About 20% of those drug sales are coming from the high and very high importance categories. When we look at the human side of things, it's closer to 80%. And so chances are, if these drugs aren't working in human medicine, it's because of the way they're used in human medicine. Now, antimicrobial resistance is a really, really complicated thing, and this is actually kind of a simplified graph showing how antibiotic-resistant bugs and genes can move through the environment from one place to the other. And CPAR's surveillance only looks at this part. They look at abattoirs and they look at retail meat, but there's a lot of other ways that these things can move. And so through the Beef Science Cluster, which is your checkoff funds, both provincial and national, as well as various other government funders, we've got a project going on with excuse me, Tim McAllister and a bunch of other people. Actually, we've got the federal government, CPARS is involved in here, provincial governments, University of Calgary, Guelph, Colorado State, USDA is involved, and consulting veterinarians are involved. And what they're doing in this study is they're collecting feedlot samples, and they're collecting manure samples, and they're collecting soil samples that this manure is spread on, and they're collecting downstream water samples, and they're collecting samples of municipal drinking water that's downstream. And they're looking at whether antibiotic-resistant bacteria and antibiotic-resistance genes are flowing from the feedlot environment to places where humans could potentially be exposed to them. They're also collecting, excuse me, samples from clinical cases, sick people, and seeing if there's relationships with what they're seeing in the water as well as in meat. And what's making this really, really cool is that they're using the latest available genomic technologies to not just look at the bugs and the DNA, but looking at the very specific DNA mutations that confer antibiotic resistance in the feedlot samples, and see if those exact mutations are what are responsible for causing people to be sick. Because if those mutations aren't the same, so if particular drug resistance that they're seeing in humans is caused by a different mutation than what they're seeing in cattle, that would tell us that cattle aren't the cause of this. And so that's what they're looking at. And in the next few years, we'll have the data. It's supposed to wrap up in 2018. The other thing they're doing through this project is getting better antimicrobial use records. I showed you those graphs. That was based on about 10,000 feedlot cattle. Here they're looking at about 2.5 million cattle in commercial feedlot cattle in Western Canada at a variety of 25, 35 different feedlots over a 5-year period. So those bars that I showed you for antibiotic use in cattle, they may shift up and down a little bit, but they'll be much more solid information. So we're looking forward to getting those. Now, the point of this presentation, which is really, really brief because I wanted to leave some time for Craig, the point of this is that there is no evidence that antibiotic use in Canadian beef cattle production is causing the antibiotics used in human medicine to become less effective. And that is in spite of the fact that people are really looking to see if that link exists. However, antibiotic use practices in our industry are going to have a much more direct impact on the health of cattle, and that's what Craig's going to be talking about starting now, as a matter of fact. So if you've got questions, I think what we'll do is wait till Craig is done, and then we'll deal with all those at the same time. Is that right, Stacey?
Yes, exactly. So, as Reynold said, if you do have questions, you can type them into the question box on the side of your screen, the chat window, and but we will save them all to the end and answer them at the end of the presentation. So with that, I would like to introduce Dr. Craig Dorin. Dr. Dorin is a managing partner at Veterinary Agri-Health Services out of Airdrie, Alberta. And his areas of interest include growth promotants, beef cattle welfare, and developing of training programs for producers as well as their staff. So, Craig, we should be able to.
Hi, Stacy. How is that?
Good.
Can you see my screen?
We can see your screen. We can't see you yet. There we go.
How about now?
There we go. Perfect.
Okay. We're good to go?
Good to go.
Okay. Well, thanks, Reynold. That was a nice preview of sort of the research side of antimicrobial use in the cattle industry. And it does sort of address the question of how much does how we use antimicrobials in the beef industry affect human medicine. But what I'm going to talk to you today about is how our use of them affects our own cattle. So I just need to, sorry, I'm just can't move my, oh, there we go. So I'm going to start this presentation with a story. And this story is a real event that happened in our practice about 3 years ago. So I've been a veterinarian for over 30 years now, and I've heard about antimicrobial resistance from when I was in veterinary college. But the reality is I had little exposure to what the true effects of that could be. About 3 years ago, in one of our feedlot clients, as the fall progressed, we entered this time frame where we were losing a lot of steers. In this feedlot, we were using a long-acting macrolide as a part of our on-arrival protocol, and that's fairly standard in most feedlots. And this particular macrolide, we had a 10-day post-treatment interval on it. So that meant that the feedlot pen riders were not allowed to pull animals out of the pen and treat them for respiratory disease for 10 days after arrival, because these animals already had a good antibiotic in their system, and using another antibiotic on top of an already functional one was not appropriate. We were losing animals at 7 to 10 days on feed. So we did postmortems on them. We came up with a diagnosis of a fibrinous bronchopneumonia, which is a pathology term for shipping fever. Our expectation was that this was caused by the bacteria Mannheimia hemolytica. And so we took some lung samples for these animals, sent them to the lab, and they did came back positive for Mannheimia hemolytica, which is what we expected. But the interesting part is all of the animals were resistant to the antibiotic that these cattle had been given on arrival. So the question we had in our mind is, have we selected for these resistant strains already in the 7 to 10 days that these animals have been to the feedlot, or did they come in that way? So the whole antimicrobial resistance question had been on our minds in our practice before this time, and so we'd actually implemented a surveillance program in this particular feedlot all fall. So every week on Tuesdays and Fridays in this particular feedlot, the processing crew would take nasal swabs randomly from animals that were arriving. We would send those swabs away, get them cultured, and identify any respiratory bacteria there, and then get sensitivities done on them. And we got lucky. And we got lucky in that 4 of the animals that had come in one group were also And we've just found that antibiotics are one of the tools that we can use, and that preventing disease was far more rewarding and far more productive than trying to treat us that were already sick. Another thing that's evolved in cattle production is the fact that we realized that certain antibiotics had key roles, and we could improve animals' growth by using them that way. Examples of that would be tylosin, when used in the feed, controls liver abscesses, and not only do animals with reduced liver abscesses grow faster, but also then we have less livers condemned at the plant, and so the total value of the animal increases as well. Now, Reynold talked earlier about monensin, which is a category 4 antibiotic and an ionophore, and that's an antibiotic that changes the rumen microflora, and it changes it so that the bugs that are still present in the rumen are more efficient, and they digest and ferment the feed better, and so we wind up with improved feed conversion and improved average daily gain. Over the decades, we've had a lot of new products come to market. I mean, way back, it was primarily penicillin and sulfonamides that we used to treat animals. But the reality is now we actually have quite a large selection of antibiotics available, and even within certain drugs, there's getting to be bioequivalents. And so our product availability is very generous, and there are new products coming, and there are also new bioequivalents coming. And so the supply of antimicrobials for beef cattle is not an issue. The real thing is, how do we use them? So throughout my career, myself and a lot of my clients, I think we kind of felt like it was our right to use antimicrobials and to use antibiotics in our food animals, and we could use them the way we wanted to. But I think we really need to change that, and we need to have a mind shift and treat this as though it's actually our privilege to be able to use these products. It's not our right. Society is going to review how we do this, and they're going to have expectations of us, and so we need to have a mind shift on how we approach our use of these products so that we can defend the fact that we're using them prudently and also in a sustainable manner. So there's going to be changes in how we use antimicrobials in food animals coming forward. In the next year or two, some of the regulatory changes that have been proposed and we are accepting or expecting to be implemented would be growth promoting claims on medically important antimicrobials will be removed. An example of a product that may fall into this category would be AS700. It's a feed-grade antibiotic. It's a chlorotetracycline sulfonamide combination, and its label claim is for use in growth promotion where respiratory disease problems may exist. So its indication is for growth promotion, and so I don't know if a product like that will be available going forward. Another change I think that producers can expect is actually more veterinary oversight on antimicrobials. There are antibiotics that are available over the counter, or they're available through feed mills without any veterinary prescription and without any veterinary oversight. And I think that that will come to an end, and there will have to be veterinary involvement in the purchases and use of all antibiotics going forward. Other changes that are in discussion now, but I don't know if they're going to come about, and one of them is our use of antimicrobials metaphylactically. And so this is a term when we use antibiotics on all of the animals in a given population to prevent disease, because we know we can reduce the incidence of the disease overall by using them in that manner. And another thing is off-label use in food animals. A lot of the antibiotics that we have, if you look at the label indications, there's only a few indications on there, and it's very difficult for pharmaceutical companies to get a label indication for a product. So they don't have the capacity to have label indications for every way that we use them. But veterinarians have the right to prescribe off-label use if they think that that's an appropriate use for a product. But there is discussion, and especially in the United States, of changing that, and so that there will not be off-label use in any of the antibiotics that are used in food animals. In Canada, this would be actually very difficult to implement. There are both federal and provincial legislations involved with the Pharmacy Act and with antibiotic use, and so I'm not sure how easy that would be, but like I said, at this point, it's in the discussion stage. So let's work through beef production cycle. We'll start with the cow-calf production. So my opinion is that this is the production sector where we actually have the best opportunity to reduce antimicrobial use. This is the non-confined component or time frame of cattle's life, and we can spread them out, and we can reduce by management changes, we can reduce the overall incidence of disease, and so obviously also reduce our need and requirements for antibiotics. But in the last 2 or 3 years, with the increase in the value of cattle, I'm hearing, and I'm hearing direct stories from producers that I've talked to, but also, you know, we hear stories in the industry in general that of people, you know, using antibiotics in case animals might get sick because the value of them is so high, they don't want to take a risk of losing anything. And it wasn't too many years ago that the cost of an antibiotic treatment was high enough that that producers used the antibiotics and used treatments quite diligently and only when they were really needed. But now with the value of calves as high as it is, and even though it has come down in the last 6 to 8 months, they're still valuable and people don't want to lose them, and so we're hearing that they are using them inappropriately when they might need treatment as opposed to when they know that they need treatment. So with some of the problems that we'd seen in our practice in the last few years, and then with the stories as what we've heard, like I just indicated, we did a little research project last summer in our practice, and so we thought, well, if we've got cattle coming into the feedlot with resistant respiratory bacteria in their nose, you know, how early can we identify bacteria like that? So we went to 4 of the ranches in our practice, and when they were branding, our technician went out and took nasal swabs on 20 calves from each ranch. And we sent they were deep nasal pharyngeal swabs, so they went to the back of the throat where the bacteria that are normally present in the respiratory tract would live. And we sent the 20 swabs from each ranch away to the lab and got them cultured. And so what you'll see here is on ranch number 1, we got 9 of the 20 calves had respiratory bacterial growth on the cultures. So the 3 bacteria that we cultured in this particular study was Histophilus somnus, Mannheimia hemolytica, and Pasteurella maltosida. And so these are the 3 of the common bacteria that we believe are involved with feedlot respiratory disease syndrome. So 45% of the culture or the calves in ranch 1 had a BRD bacteria growth. In ranch number 2, it was 8 out of the 20, so 40% of the calves were positive. In ranch number 3, we had 4 out of the 20, so 20% positive growth. And then in ranch number 4, there were no bacterial growths on any of the 20 swabs. So then we took those cultures, so the 9 on ranch 1, and we ran sensitivities on them to see if there was any resistance to the common antibiotics that we would use in the cattle industry. And interestingly enough, 7 out of the 9 swabs that we got out of this particular operation had resistant bacteria in these calves' noses. So these are calves that were about 6 weeks of age, the typical age time that you would be branding. And we also asked the ranchers to show us calves that they didn't think had ever been treated. So So to our knowledge, none of these animals had been exposed to antibiotics previously. So we've got 7 out of 9 on ranch 1, 3 out of the 8 on ranch 2, 1 out of the 4 on ranch 3, and then of course ranch 4 had no growth, so no resistance. So a bit of an eye-opener here for us, because here we've got calves young in age, never been exposed to antimicrobials, and we were culturing resistant bacteria from their nose. And as Reynold talked about earlier, we don't create resistant antibacteria, we just select for them. But you can see that they're present in these calves at a very young age. Stacy? Stacy, are you going to do a poll? Well, maybe I'll keep moving on here and we'll do the poll later. So the next component we're going to look at in the cattle feeding sector is the feedlot industry. So antibiotics are used religiously for treatment of infectious diseases in the feedlots. That they've been used that way all along. In reality, this is a very defendable use of the products. Most of the feedlots have very rigid treatment protocols. The pen riders are trained in disease recognition. These protocols are built into computer programs so that the treatments for a specific disease are very defined. The dosages are calculated by the computer. The withdrawal times are adhered to. And so our use of antimicrobials for treatment of the diseases in the feedlots is defendable, and I think is a very appropriate use of the products. As I mentioned earlier, metaphylaxis has become industry standard for high-risk calves coming into feedlots. It's proven to be a very effective tool at both reducing respiratory disease in the pens and also reducing death loss to any of the bacteria that cause respiratory disease or other infectious problem in the feedlot. But the question we have to ask ourselves is, can we defend the use of this long term? Is society going to allow us to use products, antibiotic products, on animals that might get sick that aren't currently sick? So the picture on the bottom here is one I took in the year 2008. I was out at one of my feedlots, and this is what the processing crew and the pen riders had written on one of the walls there. And that was basically when Draxxin had just come into the market. It was the first really long-acting macrolide that we were exposed to. It was an antibiotic that was effective against our common diseases for 10 to 14 days. And so the results of that were quite eye-opening for us in the feedlot industry. And one of the catchphrases that people were using for Draxxin at that time was it was a pen rider in a bottle. And so it reduced the disease so significantly that the pen riders were literally coming up to me and saying, "Are we still going to have a job going forward?" And I said, "Yes, you're not going to have to worry about that." So what I want to talk about now is some research that we were involved with Alberta Agriculture and with the Alberta beef producers a year ago. So this was the fall of 2014, winter of 2015, and we did some surveillance work on antimicrobial resistance in the feedlots. So the population of cattle that we were working with here is these were cattle that had died of respiratory disease, and for the most part all of the samples are lung samples submitted to the lab from cattle that died of a diagnosis of some type of respiratory disease. So if this is a bit of a complicated graph, but we'll work our way through it. So on the x-axis here, we've got 4 of the most common bacteria that we see in feedlot shipping fever. So in the bottom left here, we've got Histophilus somnus. And then if we move over, we've got Mycoplasma bovis. This is a bacteria that causes joint infections and pneumonia in feedlot cattle. We've got Mannheimia hemolytica, the bacteria that is most commonly associated with the classic shipping fever type pneumonia. And then we've got Pasteurella multocida here over on the right. So in this particular study, we submitted about 275 lung samples from animals that had died to respiratory disease in the feedlot. And so you can see that we had about 25 of those samples where we grew Histophilus, 96 where we grew Mycoplasma, 104, and you can see here on the Pasteurella. So on the y-axis, we've got the percent of these isolates that were resistant to a particular antibiotic. And then on the bottom here, we've got the colored bars for the specific antibiotics that we did sensitivities for. So we've got the blue bar, which is enrofloxacin, which the common name of that would be Baytril. We've got the brown bar, ceftiofur, which the common name would be Xanel, and other products with the same molecule. We've got telithromycin, which would be Draxxin, tilmycosin, which is Mycotil, and other tilmycosin products, fluorphenicol, which would be Nuflor, and then Oxytet, which is lincomycin, and the other LA or oxytetracycline products. So if we we'll come back here and take a look at Histophilus. You can see that there was only 3 antibiotics that there was any resistance to in the Histophilus. So we had about 35% of the Histophilus cultures were resistant to telithromycin. About 30-ish% were resistant to tilmycosin, and then 55 to 60% resistant to oxytetracycline. If we move over here to Mycoplasma bovis, now you can see this is a very difficult bacteria for us in the feedlot. The height of these bars and the number of them just give you a good indication of that. So for the drugs that we use on treatments with the enrofloxacin and the fluorphenicol, there was some, but only a small amount of resistance. We've got almost 100% resistance here to ceftiofur, but that bar should probably be discounted here because ceftiofur has no efficacy against Mycoplasma bovis. Ceftiofur works on bacterial cell walls. Mycoplasma doesn't have a cell wall, and so it actually doesn't have any efficacy against it, so that bar could be discounted for this. And then we've got telithromycin and tilmycosin, which we've got a high level, almost 100% of the samples that grew were resistant to those 2 antibiotics. And then again, we've got about just over 60% of the samples were resistant to tetracyclines. If we move over to Mannheim, or shipping fever bacteria, we're looking at between 55 and 60% of the cultures resistant to telithromycin and tilmycosin, and then about 70% resistant to tetracyclines. And then with Pasteurella multocida, you can see the bars here, and we did have resistance to the 2 macrolides and some resistance to the tetracyclines. So if we take a look at this slide, you can see, I mean, we have to step back and realize that these were animals that had died from respiratory disease. So this isn't a healthy population. These animals were all essentially treatment failures, and so it's a biased population as to what we were sampling, but that's what we were looking for, is the highest risk population and the most likely population to actually be able to culture and see evidence of resistance. So there's a couple of trends here. If we kind of look at the whole slide as a whole, if we look at all the red bars, you can see that, you know, there's between 50 and 60% of all the samples are resistant to tetracyclines. And if we take a look at the green and orange bars, those 2 antibiotics are 2 members of the macrolide family, which Reynold had talked about earlier. And he also talked about how you get resistance within a class of antibiotic. And that's exactly what we're seeing here, is that once we get resistance to one of the macrolides, it's the same resistance to the rest of them. So we've got about the same amount of resistance to the 2 macrolides that they did sampling for in this particular study. Another thing Reynold talked about was multi-drug resistance, which is a big issue in human population. And the question is, how much of it are we seeing in the animal population? And I think the answer based on this study is that it is growing, and it's going to be a factor. So we've got our same four friends here, H. som, M. bovis, Mannheim, and P. mult for our bacterial cultures. And then on the bars here on the bottom now aren't specific antibiotics. They're classes of each bar, so it's the number of classes that a particular growth was resistant to. So if we go back over here to Histophilus somnus, you can see that most of the samples were actually not resistant to anything. And we've got some resistant, about 20% of them were resistant to one class of antibiotic, and about 35% of them that were resistant to two classes of antibiotics. M. bovis, more evidence of resistance as we'd expect, and also a shift to the right so that we've got some of the cultures where there were 4 and a few with even 5 classes of antimicrobials which they're resistant to. And in this particular study, we only did resistance or sensitivity on 5 classes, so that was the maximum you could get. For the Mannheimia hemolytica, we had about 60% of them that were resistant to 2 classes, but most of them and the rest of them were either 1 or 0 as far as the number of classes resistance. And then over on the right, you can see a lot of the Pasteurella maltosida didn't have resistance to any of the classes, but the majority of it in there were 2 different classes. So, you know, the take-home message in this study that we did last year is that, you know, in feedlots, their antimicrobial resistance does exist, and it's an issue that we face, and the question is it going to be a growing issue, or is it something that we can control?
All right, can you hear me this time, Craig?
I can.
Perfect. Sorry, for some reason my headset wasn't working the last time, so I couldn't get them launched. But we'll take a quick break here for some of the poll questions that Craig had mentioned before. So your answers here are anonymous to everybody else who's viewing the webinar. So just click the one that best describes your answers. So what disease do you use antibiotics to prevent? So by prevent, we're meaning before signs of illness are present in cow-calf herds. So you can select all of those that apply. So yeah, once again, by prevent, we're meaning before the signs of illness, not using as a treatment afterwards. So I will just give a couple more seconds here for a few more people to get their answers in. So the answers are at birth for navel ill, scours, pneumonia, foot rot, or pink eye. All right. So the results for that one are about 35% of those that did respond said at birth for navel ill, about 24% said scours, 35% said pneumonia, and 6% said foot rot. Another question here. So do you have a set antibiotic treatment protocols for common diseases on your operation? So answers here, yes or no. I'll just give a couple more seconds here. So for those who responded, about 84% said yes and 16% said no. And our last question here. So how many different antibiotics do you have on farms? So is it 1, 2, 3, 4 or more, or unsure? Once again, I'll just give a couple more seconds for people to get their answers in here. All right. So for this one, it looks like most of them are in that 3 range with about 40%, 48%. 19% said they had 2 different antibiotics on their operation. 30% said 4 or more, and 4% said unsure. All right, so we should be back to you there, Craig.
Thanks, Stacy. So, in veterinary medicine, a common phrase that's been used in the last few years is prudent use of antimicrobials. And we've had a lot of instruction. There's been lots of documents produced on how veterinarians can help people and instruct people on prudent use of antimicrobials. So I'm going to give you just a bit of a snapshot on some ways that we can, what is prudent use of antimicrobials. So the first thing is, we shouldn't use antimicrobials for diseases that they're not indicated for. And so I've got a couple of examples of that here. It's common for calves or even older animals to get pus-filled abscesses. And so assuming the animal isn't sick and running a fever, and most aren't, then these animals don't need an antibiotic, even though just by its appearance in nature, you would expect an abscess is a massive infection, but the reality is it's a very localized infection, and all it really needs to be is drained and flushed, and the animal should do fine. And again, as long as they're not running a fever and there's not any evidence of any systemic involvement, they don't need an antibiotic treatment. Injuries aren't caused by infectious disease. So I think to myself, if you went to the doctor and said, I've sprained my ankle, can you give me something to make it better? And if he sent you home with a bottle of antibiotics, what would you think of your doctor? So it's no different for cattle. If we've got animals that have had an injury, they may need an anti-inflammatory, they might need confinement, they might need other things to help them heal up. But as long as there's no evidence in that situation that it's caused by a bacterial infection, then antibiotics are not indicated. So the first thing about prudent use is only use them when they're indicated. The second thing is what Reynold was talking about earlier, and that's understanding the different categories of antimicrobials. I've got classes here, but the proper term here would be categories. And so we want to pick products that are further away from the antibiotics that are of high importance to human health and human medicine. The next thing is using the appropriate product. I mean, products have different indications that they're good for. Different antibiotics have different tissues that they select to, or different organs that they get high accumulations in. And so you really need to have an understanding of what a particular antibiotic is used for, or is well suited for. And of course, your best source of advice there is your veterinarian. And so I think that you need to make sure you have a good relationship with your veterinarian, and so that you can talk to them about which antibiotic to use where. And one of my real actual pet peeves with use of antibiotics is not using them for the proper duration. There are some uses and some diseases in which a short treatment is adequate. So a good example of that would be foot rot. As long as it's a simple case of foot rot, one shot of a like a 3-day treatment of antibiotics should be plenty adequate to heal that up. But if you've got a calf with an infected joint secondary from a naval infection or something like that, it's unrealistic to think that a 3-day or a 5-day treatment of antibiotics will make that go away. So what a lot of people do is I hear they'll come in and say, well, this calf had this infected joint and I gave it a shot of antibiotics and it didn't get any better. So the next week I gave it a shot of a different antibiotic and it didn't get any better, and now I'm not sure what to do. Well, the reality is he probably needs a 10 or 12 or 14 day duration. And so take that 3 antibiotics and give it 3 or 4 times, 3 days apart, and then see if you get a different result, because some infections are deep rooted into the tissues and they require a long duration of therapy to have an effective result. So if we're going to reduce our use of antibiotics, we've actually got a pretty big tool chest in order to do that. And over my career as a veterinarian in the beef industry, I've come across far more situations where nutrition solved the problem more than drugs or antibiotics. Proper nutrition is absolutely the foundation of any health program in any operation. And so you need to make sure that all your cattle are getting all the energy, all the protein, but especially the minerals and vitamins that they need. And you know, inadequate vitamin and mineral supplementation is usually the problem. Most producers know how to feed to put enough condition on their animals, but they still need to have a balanced ration in order to maintain proper health. So if they've got the building blocks in nutrition, then proper vaccination protocols are definitely a way to reduce disease. And a couple of ways, and this list here is definitely not all inclusive. A good BVD vaccination program in your cow herd is fundamental in maintaining not only the health of your own herd, but the health of the animals that you sell throughout. Reproductive efficiencies in your cow herd, and then also keeping persistently infected animals out of your herd, so persistently infected with the BVD viruses, that occurs while the calf is a fetus inside the mama cow, and if the cow has a BVD virus circulating in their system at a particular time in gestation, you can develop a calf that is infected with that virus for life, and it not only turns into a poor doing calf, it also will shed virus in its feces and infect other animals around it. So in our practice, we work with natural beef producers, and so the foundation of a natural program is no hormones, no antibiotics. So we work very hard to produce healthy animals that do not need any antibiotics to become a finished product. And one of the tools that we found is that we use pre-weaning vaccination programs. So the industry standard is that you wean your calves and then you vaccinate them, or you wean them and you sell them and then they get vaccinated at the feedlot, which is what we deal with on a day-to-day basis. And the reality is then we're asking the animal's immune system to work its hardest during the most stressful time in that animal's life. But what this pre-weaning program does is we round the cattle up about 2 weeks prior to weaning, give them all of their fall weaning vaccines, turn them back out with the cows. In that 2-week period, their immune system is strong, the cattle are in a low-stress environment, and so when we wean them, we can put these same animals into a big feedlot in a concentrated environment, and we won't have any disease because they have an immune system that's primed and ready to respond against the diseases that they're going to get exposed to. So in the beef industry, we talk about biosecurity, and we're probably the least well suited for biosecurity of any of the food animal industries. I mean, the swine industry, the poultry industry, dairy industries, they all have much more closed herds, much more closed environments than we do in the cattle world. But we still have things that we can do that are a little more general in nature, but they're still a part of, you know, reduced disease, reduced antibiotic use. Examples would be not having dirty trucks come onto your farm. If you're having visitors or strangers, find out where they've been and make sure that they're not going to bring any new diseases into your operation. If you're buying new animals onto your operation, find out what the disease history and the vaccination history is of where they came from. A very simple thing is to have a protocol where you do not bring dairy calves or dairy cows onto your operation. The dairy industry has a much higher incidence of Johne's disease than the beef industry, and Johne's can be transmitted into the milk. And so I talk to my producers that if you need colostrum, don't go to a dairy and get dairy colostrum, because there's a chance that you could be bringing Johne's into your herd through dairy colostrum. Calving management, and when we talk about the poll there talked about navel ill and some other things, there's things we can do in the cattle industry to reduce our disease problems in our calving management. And one of the things that I've seen a lot of in the last few years is people calving later. While this industry was recovering from BSC in the year 2003, our cow-calf producers had to learn how to manage their costs and manage their cattle. And one of the things a lot of our clients did is they calve later. And so, you know, our big calving months used to be February, March, April, and now it's April, May, and June. So by calving later, they're calving on dry ground, they're calving on green grass, and there's much fewer problems. There's this old adage that the solution to pollution is dilution. And spreading these cattle out, using calving rotation systems like the sandhill system to make sure that you're always calving on clean ground. Low stress weaning is another thing that's getting some interest lately. The plastic devices that goes into the calves' nose so that they're still on the cows while they're being weaned off nursing, or there's weaning your calves on a hot fence so that the calves are on one side and the cows are on the other. So again, they're still able to have some indirect contact with their mothers, and it's a lower environment for weaning. Reducing auction marts and the amount of cattle that go through auction marts, and having more direct farm to feedlot sales, so that the commingling and the exposure that animals get, or these cattle get, when they go to the auction marts is a big factor in feedlot shipping fever. And so if we can take some of that stress and travel and commingling out of the equation, we can reduce how dependent we are on antibiotics. I know in our feedlot world, there's lots of times, and the story I told in the very beginning here would be an example of how knowing what the history on some animals are would allow us to adjust how we handle the animals when they come to the feedlot. So having animal information transfer with them would be a real asset in that regard. Accurate disease diagnosis to make sure that you do have a bacteria that would respond to an antibiotic, and if you're going to use an antibiotic in a situation, having some lab diagnostic results to make sure that you're using the right one. And again, going back to the story in the beginning, you know, through having an accurate diagnosis of what exact bacteria was and knowing that it was resistant to the products that we were using allowed us to change our protocol and help resolve the problem. And in the big picture, we need to have a good antimicrobial resistance surveillance program that all producers and veterinarians can use in their decision-making process. And, you know, again, back to the story at the beginning of this talk, the little surveillance project that we did in our practice enabled us to know that we weren't making any mistakes at our level, other than the fact that we had selected a product unknowingly that there was resistance to. So a few weeks ago, I went to a talk given by a veterinarian from the United States, Dr. Rick Sybil, and he works in the United States kind of at the interface of the antibiotic industry and the food industry that are selling the products that we're producing, and how society, what the expectations society has of the food we produce. And so he talked about the fact that society knows that we need to use antibiotics in food animal production. They're not opposed to our use of antibiotics in food animal production. They just want to know that we're using them prudently, we're using them sustainably, and that we are working to make continuous improvements in our processes to reduce our dependency on them. So this talk now brings us back full circle. I mean, we started out in the eye of the storm with a real life example of what antimicrobial resistance is like for a feedlot veterinarian. And now we'll come back to a cow-calf pair here that is in an environment where the disease pressures are very, very low, and the probability of them needing antibiotics and them needing intervention in the course of a disease is very low. So as Reynold talked about earlier, our industry, I don't believe, and the data would support, that we're not creating a resistance problem for the human population. But the question is, are we creating a resistance problem in our own population? And are we going to create a situation where antimicrobials are not effective for our own needs, and we're going to lose our ability to use them in the ways that we do? So with that, that's the end of my talk, Stacy.
All right. Well, thank you very much, Craig. That was really great. So now we are going to open it up to questions from you. So again, if you do have any questions, you can type them into the chat window on the side of your control panel. If your control panel has closed throughout the webinar, you should see a little orange arrow that'll let you open it back up again. So once again, just type your questions into the chat box and I'll read them out and we'll hear from either Craig or Reynold. So there have been a few submitted here already. So the first one here is for Craig. So Craig, when you talked about the branding study, you talked about the 4 different ranches. Did you look into any of the management factors that would have caused some of them to be, or the one ranch to have completely no bacteria?
Yeah, well, that's a good question, a good observation there. And I will admit that for the sake of this talk, I didn't give all of the details on each of the studies, but on ranch number 4, where there was no resistance, that was a ranch up in the foothills that was completely removed from a feedlot environment. It was a very low stress, low concentration environment where the cattle were quite isolated almost. Ranches number 1 and 2 were actually cow herds that were associated with feedlots. And so the cows in those herds would have been processed through feedlot handling facilities, and they would have actually had the opportunity for the mama cows to carry those bugs and potentially carry some resistant bugs into the herd.
All right, thank you very much. So Reynold, the next question is for you. So you talked about antibiotic use in all animals that were prescribed by veterinarians. Can you elaborate on what pet animals, how they affect antimicrobial resistance?
Yeah, and it's going to be kind of half one thing and half the other, and they're both equally important. And one is that there is some evidence that some of the and I can attest to this because I have pets. I don't own cattle, I don't own livestock, but I do have pets. And it's not uncommon for our pets, when they come home from the vet clinic, to come home with a prescription for some pretty high-powered antibiotics. So there are some pretty high-powered human-grade, weapons-grade antibiotics that are sometimes prescribed for pets. So that can be an issue. But in terms of the total antibiotic use, it's pretty small, right? Because pets are small. There's a lot of them, but they're really small, and they're not treated routinely. So whether they make a huge contribution to that total antibiotic use, I'm not very confident. I think the bigger issue, though, is that like I said, I'm not a producer. I don't own cows. I'm a consumer. I eat beef, and I own pets. And if my pets are eating antibiotics and I am eating beef, what do you think is the most likely route that I'm going to get exposed to antibiotic-resistant bacteria? It's not the beef that I eat. It's probably whatever resistance my pets are developing from whatever antibiotics that they've been prescribed. Not that that's a routine thing. We take pretty good care of them, but hopefully that answers the question. I think humans are more likely to, average human is much more likely to be exposed to antibiotic resistance due to the antibiotics that they or their family members take or that their pets take than they ever are through their food.
All right, thank you, Reynold. The next question here, so from a morbidity and mortality standpoint, how effective are on-arrival antibiotics compared to if they weren't used at all?
I assume that's for me?
Yes, sorry, Craig.
Okay. Well, they're highly effective. I can tell you that when I first started practice, and we were using a shot of long-acting tetracyclines into feedlots, our morbidity rates ranged from 20 to 40%. And now with our new protocols, and so I'm not going to say this is all due to the antibiotics, but I won't deny that I think there's a big factor or a big percentage of that. We're looking at pull rates of anywhere between 5 and 10%.
Thanks, Craig. Another question here for Reynold. So Reynold, can you elaborate on what are some of the lower priority or lower category antimicrobials?
Yeah, so the both Craig and I mentioned there's 4 categories. The 2 that are of the lowest importance, the first one would be ionophores. In Canada, Health Canada considers those to be low importance in human medicine. They're not used in human medicine. So we call them low importance here. Arguably, they should be called no importance. And in the U.S. and in large parts of Europe, actually, ionophores are not even considered antibiotics. They're just not part of the equation. They don't consider them as important at all. The second level is medium importance, and those are the tetracyclines would be the most common ones. So that's the likes of liquamycin, biomycin, those sorts of things. And then I think the sulfa drugs fall into that as well, right, Craig? So those would be. Sorry.
And fluorphenicol.
Yes, right. Fluorphenicol falls into that medium importance category as well. So then the 2 higher importance categories would be the macrolides, so the mycotils, the tylans, the daraxins, the prevos, Actran, and then the high importance are the batrils and the exceeds, XNLs, those sorts of things. I think Craig would be in a better position maybe to indicate which. Like on the cow-calf side, are there some of those drugs that are maybe a little bit more appropriate to use than some of the others? But maybe I shouldn't put them on the spot. But I just did, so sorry.
Well, I mean, the reality is, if we're going to talk prudent use, and then if we're going to talk, how that applies to the different classes of antibiotics, then we have to talk about that. And so, our high importance antibiotics would be our batrils and our exceeds, products like that. And so those are the products that are under scrutiny on how we use them. The poultry is already facing some questions on whether some of their uses are appropriate or not, and they've had to make some significant adjustments to that. So that's something to take into consideration. Our macrolides are, which are the 4 ones that you just mentioned, which are Draxin, Mycotil, Zuprevo, and Zactran. I mean, those products are typically used on arrival metaphylactically, and so they get a high volume of use in the cattle industry. So the products are in the 3rd category and less important, which would be the tetracyclines and the Nufor products. If we're talking use, that's where we need to start. Using those products first, not last.
All right, thank you, both of you, for that one. We have one more question here. If anybody else does have any other questions, just a reminder to type them into the chat screen there. But unless we do, our final question here is directed to Craig. So when we did the poll questions about treating calves prophylactically for navel ill, is using antibiotics a good choice for this, or are there better options?
Well, I appreciate why people do that, but I don't like to see that, because I really believe that the navel ill and joint infections is a management and a hygiene and sort of a contamination issue. And so I don't know the particular situations there, but my first thought, of course, would be something I alluded to earlier, and that is spreading cattle out and reducing the concentration of the calves so that they're less likely to become infected. Generally speaking, we think that these are infections shortly after birth before the navel has sealed over. In previous days, we used to disinfect the navel to try to reduce the probability of infections. We don't do that as much as we used to because we haven't seen that it actually made a difference. So my first piece of advice on that would be spreading cattle out and also calving out on clean ground.
All right, thank you very much, Craig. So I think that's about it for questions coming in. So we'll wrap things up here. So first, just a few things before I let you go here. One is how to get more information and science-based production advice through the BCRC. You can go to our website, beefresearch.ca, and click the subscribe button to sign up for our free email list. If you've got a Twitter, Facebook, or YouTube account, you can connect with us there as well. I would also encourage you to visit the Canadian Cattlemen's Association website at cattle.ca, where you can sign up for their free newsletter as well, called Action News. I would also like to remind you that our next webinar will be held Wednesday, March 23rd, and it will be on new forage varieties, so make sure you sign up for that one as well. Also, very shortly, as soon as the webinar ends, you're going to be asked to complete a short survey that asks about tonight's session and what you're most interested in for future webinar topics. We do need your feedback to do the best job that we can to deliver information that's both useful and meaningful to you and helps you make informed decisions on your operation. So please don't hesitate to, or please complete the survey and don't hesitate to contact me at any time if you have other questions, comments, or suggestions. You're also going to receive an email from me within a couple of days with a link to watch the recording, as well as links to some additional information on antimicrobial use and resistance. So that's about it. So I want to thank everybody at home for joining us tonight. And on behalf of everyone, I'd like to thank Reynold and Craig for volunteering their time and expertise tonight. So good night.
Okay, thank you.
Thanks very much, Stacy.